All right, and we are back with example 3, coffee. So they want some evidence to know if they are shortchanging customers. So remember, shortchanging means to cut them short. And so we want to know if the machine is cheating them of their full out 10 ounces of coffee when they fill up their cup. Okay, so we're starting with our hypotheses. The null hypothesis states that the true population mean of ounces of coffee is 10 ounces. The alternate hypothesis states that the true population mean of ounces of coffee is less than 10 ounces. Okay, so we're going to put that in symbols and in words, and then we're going to move forward with our conditions. All right, and the conditions are done. Notice that our n is 20, which is less than 30. So we will need to check our criteria to see if this information does resemble something that's nearly normal. And so I'm entering the information in the Inspire just to practice that. And so remember, you'll need to make sure you name your list. I just named my cup. You can name yours, anything you like. It's appropriate for the problem, so I just named it cup. And so after this, the next thing I'm going to do is create a histogram so I can check to see if the distribution is approximately symmetric with no extreme, no extreme skewness or anything like that. And then I will want to check the box plot and make sure we don't have any extreme outliers. And then I can move forward, hopefully. All right. So for the box plot, I came up with an appropriate title. So I said coffee cups, and I'm going to use the calculator and copy directly from it. Luckily for me, it gives me the scale for the horizontal axis. And so I write down those numbers. Make sure you write ounces at the bottom. I forgot. I come back around and do it later on in the video. But for now, go ahead and write ounces below those numbers because we had to make sure we have a label for that horizontal axis. All right. Have fun drawing. And now that all conditions are met, I can do a one sample T-test to determine if the machine is indeed shortchanging customers on the amount of coffee that is filled into their cup. All right, and so remember for the test, I had data, so I made sure I used the data option and I put in my information and boom, there we go. Direct copy from the calculator. Awesome. And so while you guys are writing down this information, I will provide you with some background music. Do 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 do. Oh, I'm writing. Do 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 do. Oh, I'm writing. Do 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 do. I'm writing my notes. All right, I'll come back. All right, and now it's time for the 4-part conclusion. Okay, so here we go. Using a one sample t-test, my p-value of 0.0012 is less than my alpha level of 0.05. Now remember, if they don't tell you a confidence level or a significance level or anything like that, remember it's automatically 5%, okay? And when the p is low, you do what? I know that's right. You reject the hoe. So we reject the null hypothesis here. Okay. And when you reject the null hypothesis, you have evidence of the ha. So we have evidence that the true population, almost said the wrong word. The true population mean of ounces of coffee is less than 10 ounces, which means we have evidence that the machine is shortchanging these people. I tell you. As always, if you have any questions, make sure you write them down in your notes so we can discuss them in class. All right, we're back at it again. This time we're looking at battery lifespan. Okay, so we're trying to determine if the company is meeting its goal. All right, let's start with those hypotheses. Okay. All right, so the conditions are done. Okay. Again, our N is less than 30, so we need to go through and check the nearly normal criteria. And so I'll probably speed up just a little bit so that we can jump ahead. But do understand that we have to go through that process again to check our information. All right, so now we're going to move forward with doing the t-test in the calculator. Remember, we had data points, so we're going to use the data option for setting up the one sample t-test. Don't forget to change your alternate hypothesis. And so we do a direct copy from the calculator. Hopefully you can tell by the p-value that we can, okay, I think I heard someone say it. We are going to fail to reject the null hypothesis because the p-value in this particular case was higher than our alpha level. So we will fail to reject the hoe. And remember, when you fail to reject the hoe, you do not have evidence of the ha. And then in context, you will not have evidence of whatever the question is. Okay, so And as I was stating earlier, because we failed to reject the ho, we do not have evidence of the ha. So we do not have evidence that the true population mean of battery lifespans is greater than 300 minutes, which means we do not have evidence that the company met the goal of a battery lasting over 500 hours. Oh my God, 5 hours. Sorry.